Hey guys, I'm sorry, there's kind of a hum going on in the background. I tested the video, I don't know why it's doing that, but hopefully it's not too annoying. And I definitely won't be at home making videos forever. It's just, we're kicked out of the school for a few days. Okay, so as promised, I am going to make a video going over some of the cross-section problems. So if there are 10 problems, and I'm going to do half of them. Ish, because there's actually, well, there's 12, I guess. I'll figure it out. Okay. The first thing I'll do is number 1. The base of a solid in the region in the first quadrant is bounded by the graphs of y equals 3x to the 1/2 and minus x to the 3/2 and the x-axis. Cross-sections perpendicular to the x-axis are isosceles right triangles with one leg in the xy plane. Okay. So, the fact... Sorry, I gotta grab a calculator real quick. Okay. It does say it's a calculator question, so the first thing I'm going to do is go to y equals and type that function in. 3 times the square root of x minus x raised to the 3/2. I'm going to do standard window, see what it looks like. Okay, so it says the base of a solid is the region in the first quadrant. So the first quadrant is only this region right here, so it looks like it's 0. At 0 it would be 0. And then I'm going to find that intersection. Let me zoom in a little bit. I'll just get closer anyway. Okay, so I can calculate the 0. And, okay, it's at 3. So, probably could have solved that by hand, but whatever. Okay, so number 1. I've got the x and y axis. I've got a function that kind of looks like this. It crosses at 3, and the function is y equals 3x to the 1/2 minus x to the 3/2. The cross-section is perpendicular to the x-axis, so that means I've got a vertical cross-section. Are isosceles right triangles with one leg in the xy plane. So if it's an isosceles right triangle, then it's got a right angle, and the two legs are the same. And just remember that if you have a leg in the base, that it's 1/2 the integral of the base squared, whatever the base length is. Well, in our case, the base length is just this right here, top minus bottom, which is the function f of x minus 0, right? So in fact, this one is just going to be 1/2 the integral from 0 to 3, because we're going down the x-axis. We've got vertical strips going down the x-axis, of the function, which is 3x to the 1/2 minus x to the 3/2, quantity squared, and then all we need to do is type that in the calculator and we've got our answer, because I said it was a calculator question. So, we're going to do 1/2 the integral, so alpha window, function integration number 4, from 0 to 3, and it's the function, so all I have to do is type in alpha trace y1, so for the function, but then squared, and then dx, and then my answer is going to be 3.375, or 27/8. So if you worked that out by hand, then you would get 27/8. Although working out by hand, you would have to expand this, multiply it by itself, you know, this times itself, and then multiply it out, and then antiderive each term, which we can do, but we're not going to. Okay. I don't want to do all calculator questions, but the next one is, or number 3 is calculator, so let's see. Oh, outside. Ooh, outside. Sorry, I just had to kick out the dog because she was going to throw up. Disgusting. Okay. Yeah, I'll go ahead and do number 2 because it's a little bit different, and then I'll skip 3 and 4. Well, I'll see. Okay. Okay, number 2. Number 2 says the base of a solid is formed by the functions y equals x squared, y equals negative x, and x equals 2. Find the volume of the solid if all the cross sections perpendicular to the x-axis are equilateral triangles. Okay. So I've got the function y equals x squared. This is no calculator. Okay. So y equals x squared. Got my parabola. Y equals negative x. So that is just a negative function over there, which leads me to, I mean, there's a section right there, but then it says x equals 2. So if x equals 2 is another boundary, then we're talking about this region inside here. Okay. Now, then it says the cross section is perpendicular to the x-axis. So that's a vertical strip. Are equilateral triangles. So for equilateral triangles, remember that that the general form is square root of 3 over 4, the integral of the base squared. Now remember, f of x represents the base, and in this case the base is this length right here, but that's actually from x squared down to negative x, right? So my function, or my base, is going to be top function minus the bottom function, which is negative x, so plus x, quantity squared. And then we're going down the x-axis from 0 to 2 in vertical strips. So this is expanded out x squared plus x times x squared plus x. That is x to the 4th plus 2x cubed plus x squared. And we still haven't anti-derived it yet, so we'll do that next. The antiderivative of x to the 4th is x to the 5th over 5, plus the antiderivative of that is going to be x to the 4th divided by 4, add 1 to the power, divide by the new power. So that's going to be divided by 2 because of the 2, plus x cubed over 3, evaluated from 0 to 2. All of these are polynomial expressions with an x, so I don't have to worry about the 0, but I do have to plug in the 2. So square root of 3 over 4, 32 fifths plus 2 to the 4th is 16 divided by 2 is 8, plus 8 thirds, which gives me a common denominator of 15. So I'm going to multiply this by 3, so that's 96 plus 15 times 8, so that's 80 plus 40, 120. And then 5 times, so that's 40, all divided by 15, times the square root of 3 divided by 4. Oh man, I could have divided each of those by whatever. Okay, so that's going to be 160 plus 96, so 256? 160, 250, yeah, 256, okay. So 256 square roots of 3 divided by 4 times 15. But 256 divided by 4, let's go with, I know it, but 64, right? Yeah, because that's 24 and then 16, so 64. Okay. So the answer is 64 square roots of 3 over 15. Now, I'm going to check that, because why wouldn't I? So square root of 3 divided by 4 times the integral from 0 to 2 of the quantity x squared plus x quantity squared. And that gives me that. Let's see, 64 times the square root of 3 divided by 15. Okay, good. We are there. Okay, so I've done number 1 and number 2. I'm going to leave you number 3, and I'm going to leave you number 4. Let's see. I'm going to do to do number 5. Okay, the base of a solid is the region formed by the functions y equals e to the x equals 0, x equals 1, and y equals 0. Cross sections perpendicular to the x-axis are isosceles right triangles with the hypotenuse in the base. So let's remind ourselves though. You've got squares. That's just the function squared. You've got rectangles. That's k, so some constant times the function squared, the base squared, right? Or the integral of the base squared. You've got semicircles. That's pi over 8, the integral of the base squared. You've got isosceles right triangles with leg and base, and that's 1/2. And just remember, we have 2 legs. And then with the hypotenuse and base, the hippopotamus has 4 legs, so it's 1/4 out front. And then for equilateral triangles. Equilateral, it's just square root of 3 over 4, and I remember that because equilateral triangle has 3 equal sides, so it's the one with the 3 in it. But anyway. Okay, so number 5. Y equals e to the x equals 0, x equals 1, and y equals 0. And there are isosceles right triangles with hypotenuse. Isosceles right triangles, hypotenuse. Okay. So basically we're just dealing with the exponential function, and we're going to deal with this portion of it from x equals 0 to x equals 1, and then y equals 0. So those are my boundaries. And vertical, they're perpendicular to the x-axis. So that's a vertical strip, and that means my base is the just the function, because it's top minus bottom, e to the x minus 0. So this is going to be hypotenuse 1/4, the integral. Not with this pen. So 1/4 the integral from, and we're going down the x-axis from 0 to 1, of the function which is e to the x squared dx. Okay. No calculator. Okay, so I've got to work this out. So as far as like anti-deriving the integral of e to the x squared, remember that whenever you raise something to a power that already has a power, you multiply the powers. So that's e to the 2x dx from 0 to 1. What I'm going to remember is that this is not just e to the x. I know the antiderivative of e to the x is e to the x, but the antiderivative of e to the 2x requires a u substitution. So we let u equal 2x, the function inside the other. Du is going to equal 2 dx. And then dx equals 1/2 du. So I've got a 1/2 out front, so that means that becomes 1/8. So 1/8 the integral of e to the u du. Now I'm going to go ahead and change my limits of integration. When I plug in 0 into u, I get 0, and when I plug in 1, I get 2, which means I do not need to go back to x's. So my answer is the antiderivative of e to the u is e to the u, evaluated from 0 to 2. Now this case, it's not a polynomial expression, so you can't just discard the 0. Okay, so in this case, it's going to be e squared minus e to the 0, which is 1, which means final answer would be e squared minus 1 over 8, or e squared divided by 8 minus 1/8, however they would say it. Oh, man, I really messed up that 8, but whatever. Okay. So into number 5. We're going to, I'm going to skip number 6. I'm going to do number 7. Okay, the base of a solid is the region bounded by the graphs of 2x equals y squared. So 2x equals y squared and x equals 2, perpendicular to the y-axis, and it's a rectangle whose height is 4 times the length of the base. Okay. And this is a calculator question. So we're going to set it up and then use the calculator to find it. Alright, 2x equals y squared. This is pretty obviously a sideways parabola. If you divide by 2, then you see it's y squared. So just remember, x equals y squared looks like this. And so x equals 1/2 y squared is just a little bit wider. It kind of compresses it. Okay? So I've got basically this going on. A sideways parabola. And it's both sides because it's x equals y squared, not just y equals a positive square root or y equals a negative square root. And then x equals 2. Now it does say that the cross sections are perpendicular to the y-axis, which means the cross sections are right here. Okay, so as far as the rectangles go, remember that it's the area of a rectangle is base times height, and so it would be the integral of base times height. But my base is going to be the right minus left, which we'll figure out in a second, and my height is 4 times the base, which is why it's 4 base squared, or 4 times the integral of the base squared. Okay, that's my k in this situation. So I've got 4 times the integral. Now this is a horizontal strip, which means we're going up the y-axis. Yeah? As far as right minus left goes, the right is 2, and the left is y squared divided by 2. Yeah? So it's going to be 2 minus y squared divided by 2. Quantity squared dy, but then the question is, do you want to go, like, what am I going from? What y values, right? Now, I am going to go ahead and say that this is symmetrical. So I think what I'm going to do is I'm going to multiply it by 2, and I'm going to go from 0 to here, whatever this is, right? So I'm going to plug in 2 equals x, and I'm going to solve for y. So if I plug in 2, I get 4, so that means y. If y squared equals 4, that means y equals plus and minus 2. So that's negative 2, and that's positive 2. So I'm going to go 8 times the integral from 0 to 2 of 2 minus y squared over 2 quantity squared dy. I did say that this is a calculator question, so I'm going to type that in. Now, even though there's y's, it doesn't really matter. We can use x when we type it in because the calculator will just orient it the other way and give you the exact same situation. So, not in here. 8 times the integral from 0 to 2 of the quantity 2, no, that's not 2. 2 minus x squared divided by 2 squared dx, and my answer is 34.13 repeating. So 34.13 repeating, or 512/15ths. Okay. That's 7. Let's see, you have to work out this. So I'm going to leave a non-calculator one for you. I guess I'll work number 9. Yeah, I'll work number 9. The base of a solid is the region bounded by the curves y equals x squared and y equals x. The cross sections perpendicular to the y-axis are equilateral triangles. It's a calculator question. So for number 9, I've got y equals x squared, y equals x, perpendicular to the y-axis, and we've got equilateral triangles. Okay. So, y equals x squared is the parabola, y equals x is the linear function, and they intersect at 1, 1. The cross sections are perpendicular to the y-axis, so that's a horizontal, which means my base is going to be right minus left. And this equilateral triangle, which means we've got square root of 3 over 4 out front. So the y values go from 0 up to 1, and my base is right minus left. So the right-hand function is the parabola, right? But I'm dealing with right, which means I need to solve for x. So this is x equals the plus and minus square root of y. This side is going to be the positive square root of y. So square root of y minus. And then this function is y equals x, so that's the same thing as x equals y. So y minus y. Quantity squared dy. And we type it in and we're good. So square root of 3 divided by 4 times the square root, or times the integral, not the square root, from 0 to 1 of the quantity square root of x minus x squared dx. And the answer is very small. So, this is 0.0144. 0.0144, and there we go. Okay, so hopefully that helps a little bit with the cross sections. But if you have any more questions about them, feel free to ask me individually. We can do a Google Hangout session, if it's even if it's just like setting it up or working it out. Okay.